Isn't that cool?
Yeah, pretty cool.
Yeah, man. Okay, so the first thing I want to do is kind of talk to you about like where you came from in the industry and how you got into air purifiers.
Yeah. Well, I started working in my dad's contracting company, who started in basement waterproofing. And one of the things I got involved with there is designing a dehumidifier. So we had dehumidifiers before, and it's, of course, an integral part of the business in terms of reducing moisture in underground spaces and, of course, reducing the chance for mold to grow at the same time. So we had these big, bulky dehumidifiers, and my task was to design one that was much smaller and had the same capacity. And the goal was to make it the most efficient in the world. And at the time, we did achieve that. So
Nice.
that's kind of my background, and that's how that kind of led to the air purification side. Because in developing the dehumidifier, I realized how important the airflow is, not for just the machine, but for the humans, and getting the most optimal airflow and balancing the filtration efficiency with the performance of the machine.
Gotcha. So it sounds like you were already doing mold and other air quality stuff. I mean, how much of that was home performance?
Yeah, a lot of it was home performance. I mean, you have to look at the whole space in order to get the best result for the customer in terms of air quality and maintaining the structure of their building so that you don't have rot and any other type of health issues.
The dehumidifiers that you were building, were they actually like portable dehumidifiers, like for commercial contractors and stuff, or were you also getting into actual whole home dehumidification?
Yeah, they're designed as standalone dehumidifiers to
Gotcha.
be installed in basements and crawl spaces primarily, but you can put
Nice.
them
So where were you working? What part of the states? Were you
anywhere.
up north?
In Connecticut.
Oh, okay. Gotcha. Yeah. So lots of basement. We don't have basements down here in Florida. We have crawl spaces with snakes.
Yeah,
So it's a little different. And everyone likes to keep their crawl spaces open. There aren't many sealed crawl spaces here. So it's like just mud, dirt, and a couple gators. So, okay. So you got into the air purification space. The question that I was curious about when it comes to air purifiers in general, because everyone wants to know like what's the best air purifier. So building like the perfect air purifier, the first thing we need to do is understand what the heck HEPA is, because you hear a lot like MERV ratings, and then you hear HEPA. But what is actual HEPA actually mean? Like what's the is that like a specific rating that you get on the filter, or how does that work?
yeah, great question. It's a very common question people have. And it's a little confusing out there because companies throw out the term HEPA to describe things that don't really mean HEPA. So HEPA is a minimum efficiency rating for mechanical style filters. So just your standard pleated style filters that you'd find in really any type of air filtration system, whether it's for a machine, a vacuum cleaner, or an air purifier. It needs to remove more than 99.97% of particles at zero point 0.3 microns or zero point 0.1 microns, depending on the testing standard. Europe and America can sometimes be a little bit different depending on their testing standard, but that's really what HEPA means. So if as long as the filter or the unit exceeds that particulate efficiency, then it can be considered HEPA.
Okay, so if you were gonna make an equivalent to a MERV rating, is it like MERV 17, MERV 18? Is that when you start getting closer?
That's where things get complicated because
Okay.
the MERV scale and the HEPA scale, it's not really a scale, but the categorizations are different because they have different testing procedures. So if you if you test one against the other, there's not an equivalent.
Got it. So it's
Um,
not apples to apples.
right.
Okay. Gotcha.
Right. Generally, the HEPA filtration tests are much more rigorous tests, or they're tested with much finer particles versus the MERV scale.
But it also sounds like there's different grades of HEPA too. So you can have like, well, actually, sometimes you'll go to the store and you'll see something. It's very tricky marketing. It'll say HEPA-like filter or HEPA type filter, and that's what
Absolutely.
gets you because you're like, oh, it's a HEPA filter. It's not a HEPA filter. So, but even amongst HEPA filters, it sounds like there's different qualities or grades, right?
Yeah, so there can be different classifications of the HEPA filters depending on the efficiency that they achieve in the particular test. So generally, they might be classified as like H13, H14, H15. And then you get into the U's, which is like ultra high efficiency particulate
Oh,
filtration,
wow. Yeah.
which is typically very rare that you would need that type of
Are there
filtration.
many standalones that have that rating?
No,
Oh,
no.
okay.
And the reason is that it creates way too much static pressure.
Oh,
So that's
okay.
the problem. Generally, as a filter's efficiency goes up, the static pressure goes up and the airflow goes down.
Static pressure meaning it's harder to push the air through the machine and the pressure builds.
Right,
Yeah.
right. So
So
those,
that's a problem for energy efficiency then, because the harder you have to push the air, the more electricity is being used.
yeah, energy efficiency and noise,
Oh, I see.
and your total amount of airflow too. You're going to deliver a lot less
Gotcha.
airflow if it's a lot harder to push it through that filter.
So, okay, so we know that if you, I'm trying to in my head build the perfect air purifier because that's what people want, right? They want an air purifier that does everything. And so if you have an air purifier that does everything, then you capture the most amount of pollutants that you can. A lot of times people go get an air purifier because they have smells in their house or because they're worried about, um, cigarette smoke or they're worried about chemicals. And so the first thing that I think is the education factor here is that HEPA is really good with particulates. It's not so great with chemicals and gases. It's not designed to capture those things. So if I'm building this perfect air purifier in my head, I know mine is going to want to have a HEPA filter. But if I want the VOCs out of the air, the volatile organic compounds and other gases, what do I add to that to also make sure it can remove those?
Right. Yeah. So um, there's basically 5 methods of air purification
Sheesh.
and a few minor variations on those. So you could start with mechanical filtration, and HEPA would fall into that category, which
That's
is
like
your
physically getting it out of the air,
yep.
removing it, and then the air on the other side of that HEPA, it's not coming back out. It's stuck on the filter.
Yeah, it's like
Got it.
a big sieve.
Yeah.
And then you have activated carbon, and then you have ionization and UV, and then ozone generators.
Got it.
So there can be pros and cons to all of these, but in designing an ultimate air purifier, we really want to focus on the technologies that are proven to be 100% effective and safe. So 3 of those methods can produce harmful byproducts. So in addition to mechanical filtration and a HEPA style filter, you'd want to add a carbon filter, and that's going to help remove the VOCs and odors and things like that.
Got it. So the carbon, what is the carbon doing? It's just absorbing it?
Yeah, so the carbon works by, it's actually called activated carbon or activated charcoal sometimes. And essentially, it has these little ant cave like structures, these very fine pores that absorb different VOCs from the air that are responsible for odors and other negative health effects. And those VOCs get stuck in these little ant caves and adhere to those and become trapped. And there's
Okay.
also some chemical bonding that could take place with what's called van der Waals forces inside of the carbon as well, and that helps.
So it
Remove
attracts the
those.
VOCs.
Yeah,
All right. Well, so just like with anything in life, pressure always goes from high to low, right? And VOCs also have a vapor pressure. Each VOC has a different level of vapor pressure. The reason I'm saying this is because when that carbon, like the carbon filters that I'm used to seeing are like this thin, right? They're like, a quarter of an inch thin. You can see right through it. And when that gets saturated with VOCs, like a sponge, right? Think about when a sponge gets wet. Once that sponge is at 100%, what's going to happen to the moisture in the sponge is it's going to start seeping back out. It's no different with VOCs. So when you have a VOC that's being loaded into this carbon filter and it gets soaked up and saturated, at some point, the vapor pressure, the VOCs in that carbon filter are going to be higher than they are in the air, and then it starts coming back out. So they're only so good for so long. So what's the solution to basically just having to replace your carbon filters all the time?
Yeah, absolutely. Great question. The size of the filter is really important, both for the carbon filter and for the HEPA filter. So the larger the filter is, not only is it generally going to decrease static pressure and allow you to get more air through it, quieter and with less power, but it's also going to have a greater dust holding capacity, is the term for mechanical style filters. And carbon filters are very similar. So if you have a higher volume of carbon, you're going to be able to store and capture a lot more of those VOCs from the air before it becomes saturated.
Okay, so the solution is don't use the paper thin ones. Get a carbon filter that has a lot of weight to it, basically.
Yeah, you want to look for an activated carbon filter with a lot of carbon in it.
Yeah.
So some of these filters out there that claim to be activated carbon are really just a black piece of plastic. I'm not even sure if there's any carbon in there. There might be a little dusting of it. But from all the air purifiers that we took apart, exploring what's really in there, a lot of them have little to no carbon in there.
Yeah. Yeah. And I've also, of course, this is anecdotal. This isn't like science based, but I've done thousands of inspections, and I can tell you the houses that go out and buy an air purifier to solve an odor issue, it doesn't solve it, right? I've done hundreds of VOC tests in homes that have multiple air purifiers around, and it's always the ones that have that thin little carbon filter. Just the normal ones that you would get from like, a Home Depot or Best Buy or something like that. And there's good ones out there for the HEPA. But the problem, which we'll get into later, is the way that they're sealed, the grade, and then also the volume of air that's moved. But most of the time, it's the carbon filters that I see being an issue. And so I want to bring up the actual PCO technology, PCO being photocatalytic oxidation. And some people call it ionizing, but it's really just the new fad right now, which is the oxidizing, because you said there's different methods to removing these chemicals, right? And so one of the methods is actually by trying to neutralize the chemical. So if I were going to send something out in the air, it's called a free radical. This is how the PCO devices work. So I'm going to send something out in the air that wants to steal electrons from other chemicals, because everything wants to be stable, right? So this thing's going to go out and steal electrons. And let's say it steals electrons from something like formaldehyde, which formaldehyde is hydrogen, carbon, hydrogen, and oxygen. So it's really simple. It's like literally just four things make up formaldehyde, this really dangerous chemical. So what this oxidizer is going to do is it's going to go out in the air, it's going to find formaldehyde, and it's going to steal electrons from it. And it causes this chain reaction to where the whole chain gets unstable and it just breaks apart. So now you have a hydrogen flying around on its own, a carbon flying around on its own, an oxygen flying around on its own. And what's that going to do? Well, they're going to restabilize into the most stable things that they can. So what's stable out of those ingredients? You got water, which is H2O, carbon dioxide, oxygen. So you're taking this super dangerous thing and then you're making it safe. That's the theory behind the PCO devices. Now, what I come into, and I would love your opinion on this too, the issue that I've seen, and the EPA's talked about this, and there's been studies on this, that, okay, that's what happens to formaldehyde, but what happens to things that are more complicated than formaldehyde? Something that kind of looks like formaldehyde, but has a little bit more going on. What the research has shown is that when you break that down, it can temporarily turn into formaldehyde for a short period of time before it gets broken down again. And so you're basically with these PCO devices, you're creating this chemical factory in the air, but you have no idea what is happening. You don't have any idea what's being created by these PCO devices. And I deal with a lot of people that are chemically sensitive. They go to get these PCO devices to solve a problem, and they end up getting worse because for whatever reason that they can't really quantify what's going on, but they say, "Oh, turn it back off." I don't like it. But we do have the research to show that it's producing other things that it really shouldn't be producing. The other problem too is if there's a problem inside of the unit. A lot of people, by the way, call these UV lights. They think about them as UV lights. There's two different functions of UVs. You got the UV that like shines against your coils on your air conditioner or your fan on your air conditioner. That's designed to kill things on direct contact. That's not an air purifier. That's a maintenance item. But other people will call these UV lights when they happen to have a UV light in them, but that's not their function, right? The UV light, what it does is it shines against a catalyst, usually like a titanium oxide or something like that, and it produces these oxidizers. But if something goes wrong inside that chamber, when the light is shining against the titanium dioxide, it can actually create formaldehyde there. A lot of them also create ozone right there as well. And so I'm kind of with you in the same boat. Like tried and true method is removing things out of the air, not necessarily adding these weird chemicals that not creating chemicals, but potentially creating chemicals from reactions in the air. So it's very new school way of thinking. But the reason I don't really recommend them is because I don't want to be that guy that's recommending these to everybody, and then in 20 years later, you get that commercial that comes on. It's like, have you been diagnosed with blah, blah, blah. We've been using these forever. We used to think asbestos was the best insulation in the world, and lead was so great for paint. So I don't know if that's this, but I'm a little wary, and we know the pros and cons of HEPA. We know it at the full extent. We know how activated carbon works. It's been used for decades for water filtration for chemicals. So that's kind of where I'm standing with that. I wanted to give you my whole spiel on the PCO devices and the UV oxidizers, but I'd like to get your take on it too.
Yeah, that's a great point. I pretty much agree with everything you said there.
Okay. I wasn't sure. I was like, "Ooh, are we going to debate about this?"
Yeah, no, yeah. I mean, you're making a chemical factory, and you can't be sure exactly which compounds are coming out because similar to like the process of combustion. In a perfect scenario, the products that come out from the reactants that go in. But if that combustion is incomplete for any reason, if your temperature is varied or there are other impurities in your fuel source, so in this case, how it would relate to a PCO device, if there's strange compounds going in there, you don't know exactly what's going to happen to them and what they're going to turn into.
Yeah.
And other limitations of PCO devices is they only work for very small particulates, generally organic compounds or anything like bacterial or viral. Any of the larger particles, they will definitely need to be supplemented with another either HEPA or just a high MERV rated filter.
Yeah, I haven't seen much success with those in mold. It's too complicated. It's too large compared to these other things.
Right. So PCO devices can certainly like disrupt the DNA of bacteria and viruses, and any type of organic compounds they can help with. But again, some downsides are they can produce ozone as a byproduct, which is a lung irritant, which is what some of your clients might be experiencing if their respiratory symptoms get worse from using a PCO device or anything with a UV light in it. And they can produce negative ions in the process, which also can cause different breathing symptoms to get worse.
Yeah, so that's the other thing about the ions, right? So a lot of these are ionizing. The ionizing technology, the way that it's marketed, which is actually true, is that they send these ions out in the air, and they create these I want to say, to make it easy, we'll say that they make dust like little magnets, right? So it gathers the particles in the air, and what the ionization will do is it'll clump the dust together. That way it's heavier, and it falls out of the breathing space, and it gets to wherever it's being filtered easier. So there are pros and cons to this. So the pro is maybe things aren't in your breathing space. The cons are twofold for me. One is the byproducts of creating ionization, right? Which can also be things like ozone. But also, I've noticed houses get a lot dustier because, you're creating it, it's out of your breathing zone, and now your house is completely dusty all the time because it's not effective enough to get to your filter, especially if your return is in your ceiling and all the stuff is falling. It's not really getting to the return very easily. And so I've had complaints saying, ever since they don't really connect the dots. They're like, for 6 months, my house has been getting super dusty. I don't know what's going on. And, I asked, well, how long have you lived here? Oh, we've been here for 15 years. I was like, okay, well, what happened 6 months ago? And it's always nothing I can think of. And then I get there and I investigate and I'm like, how long have you had this in your air conditioning system? That, we just got that about 6 months ago. And so that's exactly what I see happening. Now, granted, it's not in your breathing space, but it's still making the house dusty. I would say if you can get good purification in there, like good filtration in there, then the dust is reduced each time it goes through that filter, So I'm still down for 100% old school filtration, because if you're removing things out of the air instead of adding things, and that's really the safest bet when it comes to handling air quality properly.
Yeah, absolutely. Yeah, I've had our customers tell us they've had issues with ionizers, some very similar to yours as well. Yeah, and just like you said, the ionization makes particulates stick to dust in the air and causes them to aggregate and hopefully fall out of the air. What generally ends up happening is they stick to surfaces in your home.
Right.
So, depending on the size of the particles, it can be like smaller than the pores in your paint. And over time, that can cause a phenomenon called ghosting.
Mm.
So, where you get this really fine layer of particulates that sticks to your walls and ceiling and your paint, and it won't come off. And generally, we will see this aggregating more in the winter when you have colder areas of the wall due to poor insulation there, or thermal conduction through studs, thermal
Right. A
bridging.
little bit of condensation, a little higher humidity, and then the dust gets stuck to it.
Yeah, so you can actually, I've been into houses where you can see where the studs are in the
Yeah.
wall.
Yeah.
It's crazy, and it won't wash off, just
Yep.
because it's very fine. So ionizers can cause that issue, and then of course, if the dust is clumping together because of an electric charge that's being imparted to the particles, at some point that charge is going to be neutralized. So even if you get a clump of dust that drops out of the air onto your floor or any other surface, eventually that charge will dissipate, and then you're going to be left with a whole bunch of particulates that can be reintroduced into the air.
Yeah.
So you're not actually removing it from the air. You might be temporarily putting it on the ground and then it gets reintroduced into the air.
Right. Yeah, that's a great call out too, because I've seen places like commercial buildings, or even, it's a good one. A good example is things like bars and pool rooms and venues and stuff like that for music. They're always sold on ionizers because people smoke in there. And they say, oh, if you want to get rid of the smoke smell all the time, use this big giant commercial ionizer for the space. And you know what happens is you go in there and it doesn't smell so bad, but when you leave, your clothes smell horribly like cigarette smoke, you know? Um, and so I can't even go in places like that because of that issue. I'm sensitive to cigarette smoke. So going into a place that's especially using ionizers, as soon as you leave as soon as you leave the building, you just reek of it, and it's stuck on your clothes, it's stuck in your hair. And a lot of times it's actually the ionizers in there that are helping magnify that situation, because everything is just sticking to you, trying to neutralize. It's pretty gross. So, all right, so let's go back to the perfect air purifier then. So I would keep the PCO devices out. I would go with the HEPA filter. I would go with the carbon filter, but making sure it's a carbon filter that has a huge amount of carbon, right? And not the thin ones that you have to replace once a week. So, I mean, what else? Is there anything else that would perfect the system, or is that all you need?
In terms of the air purification technologies and the filters that are used, that's all I would use. As we discussed, any type of the ionization, PCO technologies, high energy UV, and ozone, we want to stay away from because of negative health effects.
Got it. Well, okay, so let's talk about the downsides then. So the downside to HEPA is that it's expensive. Having a heavy carbon filter is expensive. So the question is, if I just had a machine that had HEPA and carbon in it, I can imagine they get loaded often enough to where it's the bill's going to start racking up. So, before I bought an Aspen Air Purifier, the one that I had in here didn't have a pre-filter. It was just purely HEPA, and it's great having a HEPA filter, but it got loaded so quickly that I was like losing money because I had to replace it so often. So I think adding to that would probably be having a good pre-filter, not only just to help with the filtration, but also to reduce the load on the HEPA filter, right?
Right. Yeah. So if you can spread out the distribution of the particles amongst different filters, your filters are going to last a lot longer. So if you can capture the larger particles in one filter and allow the smaller ones to pass through that and then be caught by a different filter, your overall dust holding capacity of your unit is going to be greater and your filters are going to last longer.
Gotcha. Yeah. So this is what led me to finding you guys, because I am on the quest for the perfect air purifier. I've been on the quest for years. I've had demos sent to me. I've bought dozens of them. I've recommended things to customers, went back to their house and tested them. I mean, everything I could do to try to find the right air purifier. And I had one that I was using for a while that I was recommending here and there, but I still didn't feel quite right about it because it wasn't the best, and I felt like it was a little overpriced, and unfortunately, it didn't perform the way that it was described to be performed. But it was the best that I knew of, and I did what I could. I also like that it didn't smell like VOCs when it arrived. There are some that I notice when you get them, they're smelly, and it's like they're blowing this nasty smell out. And I'm like, okay, so aren't we here to remove the VOCs? So yeah, there was a struggle, and then when I came across the Aspen Air Purifier, I realized, okay, this thing actually has everything I need in order to filter the air properly. It has the larger carbon filter, it has the HEPA filter, it's a higher grade. It seems like a higher grade HEPA filter, right in there, and it's got this chunky pre-filter, this huge chunky pre-filter, where I mean you can keep this thing running all day long, and you don't have to worry about replacing it preemptively. So I want you to kind of talk to us about your air purifier, because it sounds like you did the same process I did, like trying to find the perfect air purifier, but instead of me just complaining, you built it. So what was the process uh, in making it? And then tell me like what you fixed in the industry with your air purifier, which thank God you did, because I finally found one that I like that performs well. But I really want to know what you did, or what's in this and what makes this one different and better compared to some of the other ones on the market.
Yeah. So um, one of the downsides of the HEPA filtration and activated carbon is that it simply blocks airflow, right? So it's going to increase that static pressure and reduce the amount of air that you're getting through it, cause greater power input to be needed, and a higher volume of noise. So those are all things that we want to reduce. So with our air purifier, the Aspen, we knew we wanted to use just the mechanical filtration and activated carbon. But then the question is, produce, how do you use those technologies in a way that doesn't block the air so much? So the design of our filters is very important. We experimented with so many different pleat spacings of the filters and different thicknesses of the filters, basically every shape. And essentially, we designed the filters before we designed the rest of the unit, and then designed the unit to fit the filters for maximum performance.
Got it. Okay. So you probably went about it a little different way than others might, just so you can maximize the way the filters are working.
Yeah. So both our first pre-filter, which we call the allergy filter, is a MERV 14 rated filter, which has relatively high efficiency itself.
Yeah.
And then the HEPA filter, they have this pleat structure that is optimized to allow the greatest airflow with the least amount of power input and least amount of noise. And then
Gotcha.
our activated carbon filter as well, we designed this grid structure to hold the carbon in place and allow an even airflow through that carbon filter and increase the amount of carbon that is being held, and also increase the lifespan of that carbon and get the air through it efficiently.
Yeah.
So those are the key design principles there. And then in terms of the user interface, we wanted it to be just the absolute easiest to use. We didn't want any fancy menus and apps and scheduling. So we kept it just really simple. You can change the fan speed with the up.
Yeah, literally just power, fan up and down, and then it tells you if you need to change the filter.
Yeah, that's basically it.
I love that.
That's what we found from experimenting with all of the other units out there, was that they're just too complicated to use. So we wanted to keep it very simple. And then, of course, the elegant design that pretty much looks good in any environment that you put it in.
Yeah, that's great. There was something on the website that I found that was really impressive. So in order to be considered a HEPA filter, you have to have 0.3 microns. You have to be able to filter 0.3 microns at 99.97 or something like that, right? So,
yeah.
But I see here that this filter is greater than 99.98% at 0.002 microns, which is great. Now, I understand sometimes 0.3 microns can be harder to filter than some of the smaller ones and some of the larger ones. But what I love is, a lot of these air purifying companies out there, they don't give you specs on anything but 0.3. And so they may filter 0.3 really well, but just based on design, they're not as good with the larger ones. They're not as good with the smaller ones. But you're actually giving us the information on multiple different particle sizes. Why did you decide to do that versus just giving us the 0.3 rating like everyone else?
Yeah, great question. So a lot of these HEPA filters that claim to be HEPA, we've done tests with particles that are much smaller than the particles required for the HEPA test, and they pass right through these. We lit it up with lasers, and you could see these particles go right through these filters. So what we found is a lot of the companies, especially the lower quality brands, the commodities, if you will, they aren't really testing their units to the HEPA standard. And if they are, they're not publishing the accurate data.
Gotcha.
And you might find another thing that is published on some air purifiers. You might find not the data for 0.3 microns or 0.1 microns, but only data for some ridiculously small particle, like 0.001 or 0.003.
They don't want to tell you about those larger ones.
Right. And the interesting thing is, it's kind of counterintuitive, but you would think that the smaller the particle, the harder it is to remove. Well, with HEPA filters, that's not really the case. There's what's called a most penetrating particle size, and that's going to be the lowest efficiency of any mechanical filter. So if companies publish only a particle that's much smaller than the most penetrating particle size, then you're going to have a false impression about the performance of it. So
you want to show all different sizes.
Yeah.
To say, look, this performs on every level, not just the small ones, not just the large ones. That was the other thing I noticed too, is that a lot of times people will look at the particle size and it'll say, 99.9% efficient at 0.03 or whatever. And I want to know, well, I don't care about that particle. That's a tiny particle. It'll go right through the pleat. What about mold? Because mold can be a 2 micron, but it can be up to a 50 to 70, 100 micron sized particle. So understanding what's going on with the larger particles is a lot of times more important depending on the use case for the air purifier. So since you mentioned the testing, I wanted to pull up this video of these air purifiers being compared. And I mean, I'm noticing the same thing that you're saying, that you have the smoke going in and then you can see it coming right back out. Now, I'm guessing smoke is various different sizes and particles, right? It's not just one particular size or.
Right. Yeah, those particles are actually they're liquid droplets that tend to range from about like 10 to 50 microns.
Gotcha. Yeah. So very, very close to around mold spores, around where the majority of mold spores. Chitomium, for example, is around 13 microns. Stachybotrys is closer to 5 to 8 microns. So, all right. So this is what kind of blew my mind when I was first looking for the Aspen, because I was looking for comparison videos. I came across this and I see the smoke going right through. And, the second best one that performed was the IQ, but you could still see the smoke going right through it. It wasn't as bad as all these, but yeah, you could see the smoke here. But this is which is still impressive compared to the other ones, right? How much? Do you know how much this unit is, by the way? This IQ Air? Any idea? I have to go look it up.
Yeah, I'd have to look it
up.
Because
I'm also in my head trying to factor cost, right? Like, okay, what's the most expensive here too? Because that should kind of relate to their quality. That's horrible. Sorry, Lavoit. All right, let's get to the Aspen.
I know that unit right there costs $4,000.
This one right here?
No, the previous one, the hydroxyl blaster.
Oh my God. Well, I imagine that they're relying on hydroxyl and not necessarily filtration, right?
Right. It does have a filter, but as you can see, it's very, very low performance.
Right. Wow. Okay. So Aspen, here you are. Okay. So you've been blowing the smoke into it for who knows how long. It's starting to build around the sides, but it's not coming out the top yet.
Right. You can see there's currently a lot of air coming out the top of it, and you can't see any particulates in there.
Oh, yeah. You could see. Oh, I see. So the airflow is keeping the particulate away. It's just blowing out.
Yeah. So that's just the stuff coming
just
up.
Clean air coming out.
Yeah.
It looks like you put a light on the other side, too.
Yeah. There's a laser on both sides so that you can see.
So you could see the clean airstream coming right out of the top of it.
Right.
Now, this has nothing to do with what's going in it, right? I mean, it's still pulling in the same amount as these other ones, right?
In fact, more. Yeah, because Aspen has a very high airflow.
Wow. Okay. So that was the first thing I'm like, okay, is it actually going in? But you could see it coming out. So yeah, that's pretty cool.
Yeah, and you can even see it being sucked in around
look at this guy.
The sides there.
That's awesome, man. Yeah. So, all right. But you guys didn't decide to put the ionizers in there, make it a little more simple. And now I see why, right? You're kind of in the same boat as me when it comes to how to make the proper air purifier. So then the question is, if I don't have any air quality issues in my house, right, that I know of at least, then do I even need an air purifier? Or do I have to have like a mold problem or a VOC problem to really benefit from this?
So it depends on the individual. Some individuals are going to be more sensitive to different particulates in the air. So some might be mold, some might be pollen.
Animals and stuff, pet dander.
Yeah. So all kinds of things. But there are certain particulates smaller than 2.5 microns in particular, which are called PM 2.5. And the reason why those are significant is because those are small enough to get into the alveoli in your lungs, the gas exchange part of your lungs, and get into your bloodstream. And then once they're in your bloodstream, they can build up a plaque-like deposit on arteries, and over time can lead to a lot of chronic diseases, even like COPD, cancer, and even heart disease.
Yeah.
So these are the things that you would want an air purifier for in order to reduce your risk of long-term illness, even if you don't have an acute issue with anything in your air currently. Like if you don't have
Mhm.
allergies to pollen like I do. Um, so I think of a good quality air purifier as cheap future health insurance.
Oh yeah, that's a good way to look at it. Well, that's what's interesting about some of the new stuff that I'm starting to look into from the EPA. The EPA is saying actually we're starting to think that the type of particle in the air isn't as important as the size of the particle. So we are worried more about the smaller particles because it goes into your bloodstream, because it's an obstruction of your cardiovascular system, which you would think, oh, wait, why is something I'm breathing bad for my heart health? Well, that's because it's so small, it goes right into the bloodstream. And where is that going to go? It's going to pass right through, through your cardiovascular system. And so making sure that you're reducing the amount of particulate, especially now that we're spending, what does the EPA say, like 90% of our time in the house or something like that? Like some crazy number. And especially ever since COVID happened, people are working from home and like just staying inside more than ever. So yeah, I like the way that you think about it, like cheap health insurance. I'll say this too. There's things, houses are getting tighter and tighter now with this new building initiative to make things more energy efficient, and nobody is implementing fresh air intakes properly. I still see 2023 houses without range hoods above their stove. And think about all the hydrocarbons and particulates from cooking, from everything you're doing inside the house, sloughing off hundreds of millions of skin cells per family. I mean, there's a lot of particulates happening in a house. So being able to have something that helps reduce the load on, your air conditioner and actually be more efficient, I could see the benefit. And I get that question a lot, like, hey, like, what if I don't have a mold problem anymore? What if I fix my mold problem? Well, I mean, I don't have a mold problem in my house, but I'm going to be running my air purifier 24/7 just to keep it cleaner in here. And I also want to create this disclaimer. An air purifier is not going to solve your mold problem. You have to find the source and you have to remove the source. I mean, it might help mitigate things temporarily in emergency situations. It's going to help mitigate and reduce things during remediation. But when it comes to trying to solve a problem, an air purifier is not going to solve a mold problem. So uh, I guess the last question I have is, what about just getting an air purifier for your air conditioner? Because the way I think about it intuitively, I'm like, okay, well, my air conditioner has a filter in it. There's a return and there's a circulatory system for the whole house. So if I just put a really good filter in that, then the air is going through it anyway, and then I just get fresh air through the whole house. It's better than a standalone, right? I'm doing the whole home. So, but in reality, there are some pros and cons. And so I wanted you to kind of walk us through the pros and cons of maybe some reasons why a standalone portable air purifier might be better than getting a whole home unit.
Yeah, there certainly can be pros and cons to both. Typically, the duct tied systems, I'll call it that because it's a little more accurate term than whole home. Um, they are described as whole home because they can get tied into your duct system. Now, there's several different ways that they could get tied into the duct system. One is it has a little fan in it and it bypasses a section of the duct. It could bypass the handler. It could be upstream, downstream. There's a few different configurations, but that induct system sometimes won't actually filter all of the air going through your duct system, which is a common misconception. The other issue with a induct system is that in order for it to be delivering clean air to your home, you need to have your central air blower on. And if your air handler is not on, you're not going to be getting any clean air to your house. So one of the problems with that is what if you're not calling for heating and cooling? Then you're not going to be cleaning the air. And how much power does that central air unit draw? It generally is 600 watts or more. So that's a lot of power, and that can have a significant impact on your electricity usage over time. And the other thing is, you could think of all of the air in your house and the air in your ducts as the same air, because it is. It's just pushing it from one room to another. Wherever you have your return duct, it's going up in your attic or crawl space or wherever the ducts happen to be located and pushing it into a different room. So it's really all the same air. So if you have a standalone air purifier, it's going to be able to clean the air in the room that it's in. That air is then going to be circulated throughout the whole house. So that's why it's a little misleading to call one a whole house and one like a room air purifier, because if you do have central air, that clean air is going to be distributed throughout the house. Another advantage of the portable or standalone units is that you can have more targeted air purification. So if you have someone in your house, whether it's yourself or anyone else, who has some sort of respiratory issue or allergies to whatever, a pet or pollen, then you can target that clean air to a specific room that they might be in most of the time. So that when locating a spot for your air purifier, one of the key considerations is who's going to be in that space and for how long, because the clean air is really for people, not for the house. So you can target the clean air to a particular location and to even a specific person where they spend their time.
Yeah, that's a good call out too, because there's a lot of people, I don't know why, but they'll call me up and they'll say, I got to get rid of these allergies in my house. I'm allergic to cats. I'm like, well, do you have a cat? I'm like, yeah. Okay. Maybe you shouldn't have a cat. I love animals, but yeah. So in those types of situations, that's perfect. I'll also add this too. There is no, not that I'm aware of, there's no sort of duct tied air purifier that has this level of carbon filtration, this level of HEPA, plus the pre-filter, MERV 13. Most of the, even the media filters, right? The 4 to 5 inch ones, most of them are actually lower than MERV 14. They're MERV 11 or 13. And so not only, like you said, is it constantly running, which is part of the same air anyway, but it's also a higher level of filtration too. So yeah, that's a great call. I didn't even think about that. Most systems, especially in part load season, like in Florida, for example, for like 4 months out of the year, our winter time, it's like 70 degrees outside. It's 70 degrees inside. How often is your air conditioner running? So yes, we have to handle the latent load, all the nasty moisture and stuff, but the unit's not running and the particles are building. So having something that's constantly running, that's not tied to an expensive to run air conditioner, is actually a great call out. And I'm assuming, based on the type of motor you have in this, it's pretty efficient.
Yeah, absolutely. We have an EC fan motor, so it draws significantly less power than an AC fan, especially if you're not running it on its maximum fan speed. And that's really where an EC fan will shine over an AC fan. And most of the time, people are not going to be using Aspen or any other air purifier on the highest fan speed, because it can be a bit loud maximum. That would just be.
Are the ECs louder or quieter than a normal AC motor, or is that not a factor?
No, for a given amount of airflow, they're going to be the same volume. But for that same given amount of airflow, they are going to use a lot less power, especially at the lower fan speeds. We actually have a graph showing that on our website of Aspen's actual fan speed. But I wanted to touch on something you mentioned with the ducted systems. Yes, they are going to have a lower efficiency, and that's because if you are trying to push a lot more air through them, the static pressure is going to be a significant factor. So one thing I want to stress is you should not put a very high efficiency filter in your central air system. And the reason is if you have air conditioning tied to that, what you're going to do is increase the static pressure, decrease the airflow getting to your air conditioning coil, and then that's going to change all the pressures and temperatures in the refrigeration system. And basically, you're going to freeze your coil. So if you
Hmm.
freeze your air conditioning coil, it could potentially cause damage to the coil. It's going to limit its effectiveness. The efficiency of that's going to go down, and you're going to get a lot less air delivered to your home. So definitely do not go and put like a MERV 13 filter in your air conditioning system.
Right. It's so funny because I was thinking about media filters because I'm so used to just working with the big 4-inch ones. But there are so many customers that try to put a 1-inch filter in there and they try to get the highest grade one that they can. And because there's so little surface area and so much pleat that your air conditioner is working very hard to try to pull the air through filters that are too highly rated. And just like you said, especially here in Florida, it's a problem because when that air goes across the coil slower, it causes the air to become colder. And the first place that we notice it is on the supply vents because the dew point here is a little higher. And so the supply vents will start to sweat, mold will start to grow inside of the register boots, inside of the air conditioner. It'll start growing on the wiring and the housing, the blower motor. All of this mold growth will happen before your coils even freeze and you even notice. Now, not only that, but because your fan speed has to ramp up, it causes an energy efficiency issue. And so, yeah, that's a great call out. It's funny because I didn't even consider those. Honestly, I don't even consider 1-inch filters. Those are just maintenance items to keep the air conditioner, healthy and not overloaded. They're not enough to filter the air in your house. I always consider those maintenance items. Once you start hitting the media filters, then you start getting a little bit somewhere. But yeah, that's why I think something like this is probably the ultimate way to do it. So I think that I have so many more questions for you, Tanner, but I don't want to take up too much of your time. I know you have a meeting coming up too. Thank you so much for joining us, giving us some education on this stuff. So if they want to learn more about the Aspen Air Purifiers, how do they reach you? I have a promo code here. The promo code is ABSA, ABSA, and the ABSA promo code will get you some money off of the actual Aspen. But you have some great articles on your website, things that they can learn more about. So how do I direct them to you?
Yeah, anyone can go on to elementalAirSystems.com, and then we have a tab right on the top of the page for our blog, and we have a lot of different resources, a lot of some of which we have already talked about in our discussion here. But if you want any more detail, you can go there and find out more.
Nice. I'll also say this: your YouTube is great. You have some cool stories on there, and you have some more information about the Aspen where they can actually go and look at it, look at the internals, and understand what's going on with it. So, thank you so much, Tanner. I appreciate you coming, man.
Yeah, thank you for having me.